Welcome to math class. Today we will be going through slides together and working on some problems, moving into solving for x. Please make sure that you have all your supplies with you before you get started. You will not need markers today. Take a second to read the introduction, and I will read it along with you. So today we're going to continue to simplify the tiles, but we're going to add the equal sign finally and make our expressions equations. As we work through today's problems, I want you to keep a couple of questions in mind. How can I simplify this? And how do I get x alone? What does that look like? Is there more than one way to do it? If you worked with your elbow partner, would they have a different way to solve it? And is there always a solution? That last one is something that we're going to just dabble with a little today, and we will really process that on Thursday together. So our learning target for today, being mindful of what your expectation is when you leave the classroom, is that I can simplify expressions using our legal moves and then now solve for an unknown variable. And I can justify my solution. So we're going to have a conversation about what that means. So we're going to use the tiles to understand. The process is a little bit clunky, so it says open your iPad, which of course it already is. You're going to go into modules, and in the special notes, you're going to see a link that will say tile problems. And I need you to split the screen and have one side be this video and have the other side be your Canvas page so that you can click into those tiles. When you click into that, you will end up at a page that is on the next slide. So let's go there. So when you click on the link from Canvas, you're going to get here. We're going to do each of these two problems together. You're going to be working through it online, and I'm going to be a little clunky because I can't figure out how to get the link to actually work in this slide presentation. But click on the first link and I will meet you there. Okay, so what you have on the right-hand side is your equation. 3x plus 2 is equal to 11. And you can see that on the left-hand side of the mat, we have 3x tiles. And then on the right-hand side of them, that's these right here. And then on the, we also have two unit tiles. Then we have our equal sign. And then we have these 11 unit tiles. So that's what we have, and that's what we're going to end up working with today, is all of that. We also have the equation over here on the right. So the first thing that I want you to think about is balancing as an idea of getting x on one side of the mat, usually this side, and all of the other numbers on this side of the mat. So one thing that you can think about is if we have these tiles right here, we really don't want them there, do we? Well, how do we remove a tile? We remove a tile a couple of ways, by a balanced set or by making zeros. So let's think of the idea of a balanced set. If I have these two tiles here and I have these two tiles here, again, I'm using blue, I can take both of those away using the idea of a balanced set. I can do this and I can do that. And what does that leave me with? It leaves me with my 3x tiles, and then it leaves me with 9 unit tiles over here. So if I took each one of my x tiles, I'll just do that to show that they're positive. You won't have to do that. But if I separated them so that they weren't in a line, and I have these 9 individual tiles, and I asked, how can I evenly distribute these 9 individual tiles for each one of our x's? Well, hopefully it makes sense that each one of the x's would have 3 of the unit tiles, so that it was even. So each x, because each x has to be exactly the same value, right? Because it's the same variable, has to be equal to 3 unit tiles. So that's the idea of what we're doing. I'm going to show you on the other side what that looks like algebraically. The first thing I would like you to do to begin is to just put a line here to show kind of this line right here. And what did we end up doing? We ended up removing 2 unit tiles. So we removed 2 unit tiles from each side. That's what we did. We took them away. So last year, hopefully you had the idea of making a 0. That's what we were doing. But this idea of subtraction is actually removal. When we do that, we ended up with these 3 X tiles, and then we had 9 more unit tiles left. And what I said to you was, we want to evenly distribute. We want to divide each of the X tiles into the 9 tiles. So if we are dividing and we make a fraction, we don't use the division symbol. You have to do it on both sides, right? Because we wanted to divide that 9 tiles by the amount of tiles that we had for X. So what we ended up with, X was equal to 3, meaning each X tile was equal to 3 unit tiles, which is what we found on our mat. Now the caveat that we have here with tiles is that with equations, is that we absolutely must, without any hesitation whatsoever, absolutely have to check our solutions. So what you will do after you do something like this is you will write the word check, and you will rewrite your equation. You will say 3x plus 2 is equal to 11, and you'll say when x equals 3. And that's what we're trying to prove. And you've seen this before in this class. So what we're going to do is we're going to use good algebra standards, and we're going to replace the variable with the actual value, plus 2, and hopefully that's going to be equal to 11. 9 plus 2. And does that equal 11? 11 equals 11. So it is true that x is equal to 3. And that is a complete algebraic solution. Okay, I've been sitting here trying to play with that equation because the 34 is not in the right spot, so we'll have to rewrite the whole thing. So a couple of things that we want to think about here is we want to take a look at what we have. We do have 7x tiles, so check. I'm just going to rewrite the whole thing. So 7x. And then we also have 2 negative x tiles. Okay, and then also on the left-hand side, we have 10 unit tiles. And then on the right-hand side, it looks like we have 1x plus another 2 x's, and and then it looks like we have 34 unit tiles, which feels like a lot. So before we want to start moving things around, it's always helpful to try to eliminate things using the idea of combining like terms. So if we go into the idea of combining like terms, you can see that we could take all of these and we could push them off of our mat, right? So when we do that, what does that leave us with on that left-hand side? That leaves us with 5x and still plus 10. When you look at the equation, you are combining these two right here. And again, we did that on the tile mat next to you. Let's take a look at the other side. Again, we would want to combine our like terms, right? We'd want to combine all of these. So what does that look like? That looks like 3x plus 34. So again, we combined our like terms. So that's the first thing that we want to do. Now, we talked a little bit earlier about getting all of our unit tiles to one side and all of our x tiles to one side. So let's try to see if we can use the idea of our unit tiles, our x tiles rather, and getting them off of our mat first so that we can kind of simplify. Well, I have 5 over here, I have 5x tiles over here, and I have 3x tiles over here. So if I was going to remove a balanced set, I could remove the 3x from each tile. So if I moved 3x from here, I would end up with 2x tiles. So what I could do is I could take all 3 of these and I could move them off because of the balanced set. And then I'll just take these 3 and I'll move them off because of the balanced set. So remember, removal is an idea of subtraction. So if I'm taking the 3x tiles away from each side, because I'm removing them, making that actually end up as a 0. Oopsie. Sorry. Too many buttons. What do I have left? I have 2x, like we said, plus 10. And then on this side, I have 34. So let's look at the balance sets again. If we use the idea of the balance sets one more time, I have 10 tiles over here, so that's 10. And I can remove 10 tiles over here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be these guys right here. And I'm going to remove them also off of the bat. So removal is negative, so I'm going to remove. Okay. So when I do that, I end up with 2x just on the left, which is good because I want to isolate my x tiles. And then over here, I end up with 24. So in the last example, what we did was we ended up figuring out how many each one of these x tiles would be equal to, right? So you have the ability to take all of these and move them around. So if you take those tiles and you end up moving them around, I hope that you end up seeing that you would have 12 of them here and 12 of them here for a total of 24. So what did you do? You divided the tiles by 2. So the words are divide by the coefficient of x. That's a big word, and we will do vocabulary tomorrow. So x would equal 12. But again, we are not done. We have to check our solution. So we're going to have 7x minus 2x plus 10 is equal to 1x plus 2x plus 34. And that is going to be hopefully when x equals 12. You have to write the original equation down. So 7 times 12 minus 2 times 12 plus 10 is equal to 1 times 12 plus 2 times 12 plus 34. So 7 times 12 is 84, and then 2 times 12 is 24 plus 10. I usually like to finish one side completely and then move on to the next. So 84 minus 24 is 60, plus 10 is going to get us 70. So that's my goal, is to get 70. Let's see how I'm going to do. So I have 12 plus 24 plus 34. So that is going, okay, so 12 plus 24 is 36 plus 34 and 70. So it works. Well done. Okay, so these tile problems, they can help you with understanding how you're solving and simplifying on the mat and how that translates to solving without the mat, which is where we are headed right now, is removing those mats completely. So here are your steps. You must work step by step, one step per line. You cannot combine steps ever, 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 ever. You must show all of your steps, especially when you check. You have to use this funnel down approach, and again, you must check. You will be graded on all of these steps. Okay, so at this point, I would like you to get the class worksheet from your teacher, and I'm going to do the first one together, so you can either continue to watch the video or you can work on it on your own. Either way, there's a key for all of the problems up at my desk. Okay, so here's our very first one. So we have 3x minus 7, and that is equal to 2. And the deal with that is it's the original expression. So what we want to do is we want to remove the 7s so that we can have just the x's on the other side. So we are going, our move is going to be a balanced kind of. We're going to be removing the negative 7. So in order to remove the negative 7, you have to do the opposite of that, which is plus 7, because you want to be making a 0, and you have to do it on both sides. So again, understanding that this is the idea of removing that, or adding at this point, really, because we're adding a 7. When we do that, we end up with 3x is equal to 9. Okay, so that is our result. So now what we want to do is we want to distribute the 3 and the 9. We want to equally divide it. So we are going to divide by the coefficient of x, and that number is a 3. And we have to do it on both sides, and we do it using a fraction, not a division symbol. So 3 divided by 3 is 1, so we have x, and that is going to be equal to 3. So that's what we think our solution is. And what we want to do now is we want to check. I always use a different color. So we go back to our original expression. We have, that's twice I've done that. So we have 3x minus 7, and that is equal to 2, hopefully, when x is equal to 3. So you must show your steps. That's why we've been practicing this. And that's going to hopefully equal 2. 3 times 3 is 9 minus 7. And 2 does equal 2. So your answer is x is equal to 3. And that's how you solve an equation. So please complete the classwork problems and check them. And last but not least, the RMP for today, if you are on a full block, is number 58 and 64. I will see you tomorrow.